All right, so here we'll look at thyroid and the parathyroid glands and what hormones they produce and secrete. So let's begin by doing a little bit of anatomy review. And so the thyroid gland is going to be located just below the larynx, and it has two different lobes on either side of the trachea, which are going to be connected by a little stalk called the isthmus. Now, there are different types of cells that we find within the thyroid. The first type are the follicular cells, which we see in this histogram or histograph, and these are going to be those purple stains that are surrounding those larger conglomerates. And so the follicular cells, the purpose is that they serve as a storage site for thyroid hormone, but their arrangement is in these hollow spheres, which they have this lumen here called the colloid. And the functional unit then of the follicular cells are going to be these follicles. And so within the follicular cells, we'll have the production of two different types of iodine-containing hormones that are derived from the amino acid of tyrosine. So we have T4, or thyroxine, and T3, which is triiodothyronine. And we also have another set of cells called the parafollicular cells, or the C cells. And so these are going to secrete calcitonin due to high levels of blood calcium levels. And so calcitonin, the function here is to decrease the amount of blood calcium levels and to deposit that calcium back into bones. So the parafollicular cells are going to be what are on the outside of the follicles. So that's where we'd find those C cells. The thyroid hormone plays a main function in the metabolism and growth of us. And so it's going to be the main determinant of our basal metabolic rate, or BMR. It also will help to influence synthesis and degradation of carbs, fats, and proteins, and it helps to stimulate protein synthesis. It also increases target cell responsiveness to catecholamines of epinephrine, norepinephrine, and dopamine. And so it also helps to promote the maturation of the nervous system as well. We also have an increase in heart rate and force of contraction, and that also, the thyroid hormone is essential for normal growth and development, and also plays a crucial role for the increasing the rate of cellular respiration as well. And so problems that can occur are that with stress, and so long term, this could be very detrimental. And one other example is cold temperatures within infants. So stress is going to inhibit the hypothalamus, and then however, cold is going to influence or increase and activate the hypothalamus. Then what will happen is that, so if let's look at first the stress response. With stress, then that means that the thyroid tropin releasing hormone from the hypothalamus is going to influence the anterior pituitary and will influence then the thyroid gland, where this will no longer then secrete thyroid hormone. And so with stress, then we have actually a decrease in metabolic rate and heat production, and then a decrease in growth and development of the central nervous system. However, with cold, this is actually going to increase these responses. So we'll have the hypothalamus make this TRH, and then we'll have thyroid stimulating hormone be released, and then that will increase the production of thyroid hormone, then will increase metabolic rate and heat production for that cold infant, and then that will then start and help to increase growth and development of the central nervous system. When we have dysfunction of the thyroid gland, we go into either hyperthyroidism, which is too much thyroid hormone that's being produced, or hypothyroidism, which is too little thyroid hormone that's being produced. So here's a great example of what will happen. So if we focus first, let's look at hypo, too little of thyroid gland or hormone. So with growth and development, this will impair growth. It will lead to an increased amount of sleep, an intolerance to cold, so no matter what, you cannot get cold, warm. Also, dry, coarse skin appears, lack of perspiration, a slow pulse, also constipation, a decrease in appetite, but an increase in weight gain. Your reflexes tend to be a lot slower. Depression and apathy tend to occur, as well as a decrease in circulating thyroxine levels. Hyperthyroidism, though, has the opposite effect. So too much of the thyroid gland will lead to very accelerated levels of growth, increase in activity, but decrease in sleep. Intolerance to heat, so always being hot. Normal skin, though. Excessive amounts of perspiration, rapid pulse rate, frequent bowel movements, an increase in appetite, but then a decrease in weight gain. Fast reflexes, nervous, emotional state, and then also an increase in circulating levels. So here in this example, this is an example of a goiter. And so this is due to an iodine deficiency that's due to overstimulation of that thyroid gland, and because there's no negative feedback on the pituitary gland, and so that leads to the growth of a goiter. And so now, though, in our developed countries, we've added iodine to table salt, and so this has really combated the symptom of having the goiter amongst our nations. Then the parathyroid glands are 4 glands that are very small and are found on the posterior side of the thyroid gland. And so they secrete a hormone called parathyroid hormone, and this increases calcium levels in bone or in blood by bone reabsorption, and then also is stimulated when electrolyte levels are low from sweating or with excessive urine formation. And so this will have an antagonistic effect on calcitonin produced by the C cells within the thyroid gland. And so if we look here at this figure and flow chart, so when we have a decreasing blood calcium levels, this is going to then activate the parathyroid glands. And so the parathyroid is acting as all 3 of the sensor, integration center, and the effector. So the parathyroid glands then will produce parathyroid hormone and then release it out into the kidneys and then into the bones, where they'll have an effect there. So within the kidneys, this will reabsorb calcium from urine, and then from bones, this will start the breakdown of calcium from bone. And so all of which the response then is to increase circulating blood calcium levels until we go back to normal, so in a negative feedback fashion. And so then within the kidneys, then we excrete a smaller amount of calcium so that we're able to have that circulate within the bloodstream.